Okay, good afternoon, everyone. Today, at the beginning of this session, I have the pleasure to present the next five articles, papers, whatever. So, today we will start with Alexandru Marian Galea, Bogdan Sebachev, and Silvia Marzavan from Military Technical Academy, Ferdinand I of Bucharest. The presentation from today is entitled Automatic Detection of Objects, Chromatic Components in Images. So, normally for all of you that are following us online and live, so you'll have a 10 minutes presentation and then we keep 5 minutes for questions. So, please go ahead.
Greetings to you everyone. Today I will come in your attention with a topic about automatic detection of objects' chromatic components in images. As an outline, I will start with the introduction, then go through program statement, the methodology overview. I will then go with the results. I will expose my future directions, and I will come to a conclusion in the end. So, the aim of artificial intelligence techniques are to mimic the visual perception of the eye to uh, come to the same results as the eye, to see the world as the human see the world using AI. For that, we have to get through some challenges in the means of lighting condition, object textures, and environmental influences. As my methodology today, I will get you through instance segmentation, the first part of my method, then go through segment anything model, then finally with the color extraction framework that is fast color fit. What is instance segmentation? What is important about instance segmentation? Is the fact that we don't only identify and separate masks from the image, it's the fact that we separate things that we know, like known objects, known labels. So our models will try to detect and construct masks of known objects in that image. In this image, you have uh, cars that were segmented by YOLO model. Now, a sub-instance of instance segmentation is single-shot instance segmentation. That means the detection and the segment part are done at the same thing, at the same time. Uh, YOLO is a YOLO Act inspired architecture. It's a well-known architecture that many segmentation uh, archi- frameworks are inspired by. So, YOLO say uh, it's built upon the default you only look once detection framework. In addition to this, we have the part of segmentation, that is this one. We have three main components, the backbone part, the neck part, and the head part. In the backbone, we do uh, the extraction of features with the convolutional networks. Then in the neck part, we process them. Then in the head, we refine the outputs. So here, simplified again, convolutional networks for feature extraction. Then the process part in the neck. Then in the final prediction in the head, we have two heads, the detection one and the segmentation one. And the last part, the post-processing part, where we refine the output. My middle part of the project is a segment anything model that has three main characteristics that are instance agnostic, class agnostic, and flexible and adaptive. You may wonder what instance agnostic and class agnostic means. So, for all, we refer to no fixed classes, no specific instances, and delineating objects based on the boundaries. So we don't have known objects that we want to find in that image. We just separate the objects in the image based on their boundaries. This is its architecture. It's also based on YOLO V8 backbone, so the convolutional network part. Uh, then we have a feature pyramid from which we extract the third level, the fourth one, and the fifth one. We extract from it the mask coefficients and the detection labels, and we combine them with protonet prototype masks that are generated, and we customize that mask to approach reality. In the final step, we refine the the whole process of detection. So similar labels are put at one, and the final thresholds are generated as you see here. Next, I present you an image of a car being segmented by PASM and his predecessor that was a heavy transformer model. As you can see, the results are comparable in terms of performation, but the time of PASM is far superior to his older model. Now, in the last part, the color extraction model that is fast color tip, and it's based on median cut quantization algorithm. Really important to note is the fact that this backend was written in C++ for better performance than used in the Python. Here, I present you the equation that summarizes the entire process of fast color tip. So, the resulting color of the final pixel of one of the final pixels is the average of every pixel in that region. The whole region, the whole image, is composed by the K clusters that we want in the first step to obtain. So the colors that we want to obtain. And every region is obtained by multiple application of median cut algorithm on previous regions. Here, a more suggestive explanation from 16 million colors in the original image, we in the end have only 16 clusters of colors that are mentioned here using the average process. Now, my implementation that focuses on two main parts, on vehicles and humans. And also my objective to accurate detect color in vehicles. Again, my key components were the frameworks that I already mentioned, YOLO V8, FASM, and Color T. And now how my implementation works. So the image with the car is passed to the YOLO V8 framework that generates masks and labels from that image. We have labels from Coco in the pre-trained model that I use. Coco is a data set that has 80 categories in which are cars or type of cars or type of vehicles and also people. From that, we come with the question if the label is a vehicle. If it is, we apply the mask that we get and we remove the background from the car. After that, we pass the car in FastSem framework and we get from it masks of different components from it. So we sort the resulting mask by surface, and the biggest one is the hood of the car. We extract the hood of the car using FastSem, then we pass it through fast color tip that makes four clusters of colors from it. Now, regarding people, again, the same objective to accurate detect color in people clothing. As a difference from the previous implementation part that I described, at the middle I use mathematical body proportion. So from the upper part I extract this region, and from lower part of the clothes I extract this part here. Now, a similar approach. We pass the original image through YOLO V8. We get masks and labels. We put a question if it is a human. If it is, we remove its background using the mask. After that, we apply body proportion. We get the two parts of the body and the clothes, so the superior part and the inferior part, and each of them are passed through fast color tip, and we obtain color clusters. As future direction, I want to improve the middle part in people clothes, so I found a neural network called segformer B2 clothes that seems to be efficient in separating clothes in different scenarios. But future tests are scheduled to be done. Conclusion: I think I managed to get through color extraction difficulties, the lighting condition, the object texture, the environmental influences. I think my research integrates successfully advanced models like segmentation models, YOLO V8 and FastM. Also, some study about mathematical body proportion. And I think that I found an efficient color extraction model that is fast color tip. These are my references, and I want to thank you for the attention.
Thank you. If you have questions from here from the room or from those who are joining us today online, please feel free to ask questions. So we have 4 minutes for questions. So Johnny. Okay, thank you so much.
Thank you.
So we will see if we have um, well, the presenters from France, because otherwise, if we do not have them here, we skip with the next person who's live here in the room. So normally we have after Latifa Butadvadas, there is Roxana Dobre, Bogdan Sebaker, Silvia Marzavan. So let me know if you are here. Okay, good. So the title of the presentation is Geological Soft Data Integration for Phases Probability Fields using a regularized element-free Galerkin method. So you know the rule. So you have 10 minutes presentation or 12, and then final questions. And please feel free to ask questions as well. Good.
Hello, we are talking today about regularized elementary galaxy used for geological soft data integration. In order to talk about this subject, we must understand how it works the reservoir engineering world. So we need to focus on maximize the efficient extraction of subsurface fluids. In so we must work with the challenges in reservoir exploitation, like geometry that is very complex, and we are talking about large scale simulation. So we need high computational demands due to time dependent behaviors. Before the production begins, we need to understand the geology of the reservoir and to make the modeling of this reservoir of oil. What do we need? We need some prior information about rock types, spatial distribution, phases, direction, phases observation, and well location from the oil reservoir. One method that we are using in this presentation is phases probability method. That it helps to understand and modeling the spatial distribution of rock types. For this, we need two geological information. So we need geophysical analysis using we're using an inversion technique, and we need also information from the geologists that study the core extracting from wells. Also, these two pieces of information are uncertain and uncorrelated. So we must to put in a unique way to work together. First phase is from seismic data interpretation using seismic inversion to convert that seismic data into quantitative rock property model. From here, we are using phases geometry and phases probability curves. Other phase come from the geologists who use well data and core sampling that will be studied in order to see the rock layer at the subsurface. Using all this information, we are modeling and try to find the reservoir model. The problem is that the reservoir dynamics are governed by unobserved process. So we have huge uncertainty and we must modeling this uncertainty. How to do this? We must found some prior probability fields, and for this we are using first, how I said, the probability field of phases from seismic inversion. It looks like that. And from the geologist in the wells, we have hard data or soft data observation. Hard data will be 0 or 1 if we have oil or we don't have. The soft data is more subjective and takes into account some uncertainties. The choice of this value can be based on expert opinion on or historical data. So we have these two information and we try to use both. We combine this, the seismic observation and the observation from wells, and we have an image of a layer where we have the probability of oil reservoir. How we are doing this? We are using element-free Galerkin method, where the probability will be updated using a function of location and the parameters. I outline on short element-free Galerkin method. It's a match-free numerical technique, but it's very useful in that case because we have flexibility for complex domain. Okay. Other important element is that use node instead of connected elements, so we can construct shape function without predefined connectivity. We are using least square method, so we have some point where are the wells, and we minimize the function using a weight function that calibrates the influence of observation with the location. Okay, so we must find the minimum argument of function j. So we have observation, and using that function we can calculate the approximation of a value in other points. In There are many weight function used in this method, but for reservoir modeling, we choose from that three function: quartic spline function, cosine function, and elliptic function, because they are stably and efficient in problems involving anisotropy. So these are the functions that we are using. Also the weight function depending on the anisotropy properties. So taking into account the influence in one direction, that is stronger in one direction and lower in other direction, and minimize that function and found the value of the parameters A. The problem is that we have few locations where we have observation, so we must to generate a mesh using a trick from the finite element theory. So we have only the value, and we choose in the corner the medium or the same value depending how what value do we have. The problem is if we are taking into account only the weighted function, that if the location is too far, then we don't have to be optimized. So we are putting a new term, name Tikhonov term, regularization, and we that take into account the probability from seismic. Okay, so for our problem or our study case, we have three facies types. We modify the cast function for these three types of rocks, and we try to find A1, A2, and A3 to minimize with least square method. We have the solution, and now we are taking into account some variation of the inputs. So we're taking into account the wave function, the anisotropy parameters, and the Tikhonov parameters. We have the initial three fields from seismic inversion and from observation. And if we have the different function, we obtain different value depending what function do we use. Other results are influenced by ranges of range of short and angle. If we change the range, also we obtain another value for every case. We try to change the angle to see what happened, and we take into account different value of the angle, and also we try with different Tikhonov parameters influence. In all the cases we have different answer, and also use soft data and hard data for probability, and again we have different results. So in our using that element-free Galerkin method, we verify that it's very sensitive to parameters, and the calibration are the user choice. So we can tell what choice is better, but in the future we will try to use our works to make a history matching procedure with the observation data that we have. And I outlined few references from this reservoir modeling.
Thank you so much for your presentation. Please let us know if you have questions. So I will repeat till the end of the day if you have questions here in the room, but also for those who are joining us online. Okay. Yeah, so you can step few steps here in front. Okay.
Okay, so my was camera.
You cannot hear. Maybe for those who are joining us online.
So basically, my question is, how does the integration of the soil geological data affect the accuracy and stability of the facies probability models compared to only using hard geological data?
I don't have an answer because we didn't make the history matching. So we are we have the modeling with soft data and with hard data, but we didn't compare with the old observation to see if which is better.
Okay.
So we don't know yet. Is the next future to do this?
Understand.
Thank you.
Thank you so much. I was just trying to fix the online next presenter, but till that we do not have her here yet. So I will ask Tudor Siracheanu, Ana Maria Micu, Cătălin Andrei Neagoe, Mirela Roxana Aptan, Nicolae Pop. They are from Timsari, Solid Mechanics Institute from Bucharest, Romania. Their paper is entitled Non-Destructive Methods Based on the Vibration Response of Some Structural Elements Made of Composite Materials.
This paper describes some non-destructive methods based on vibration. Response of structural elements made of composite materials. The problem of determining the material constants are Young modulus and the transversal modulus of elasticity is not a very easy task, because these materials we are speaking of, what is this? This should be are very amorph materials. They don't have isotropy, they don't have homogeneity, so they are very erratic. They have very erratic structure. I have here some samples of these materials, and you can see, if you want to, if you want a later one, I can show you these materials, which are, very, very difficult to reproduce, even in a well-controlled manufacturing process. So the purpose of this paper, you can see on this slide, and the research motivation, characterization of innovative materials with increased structural complexity. And the other ones here, I don't read what is written there because you can. So here are some a picture presenting some materials, some kind of materials with different kind of natural fibers, which can be will be here. You can see here these ones: hemp, flax, sisal, willow, poplar, jute, and other kind of materials which are not even long fibers, just they are spread on a polypropylene base, and then they are pressed with the pressure, which is this is not here. Oh my gosh. So this, the research objectives are determination of longitudinal modulus of elasticity by experimental determination using free vibration testing, and validation of the experimental results by using FEM. The same research, the same procedure is made for transverse modulus of elasticity. Here are some problems with the equations, but the free vibrations of cantilever beam are used in order to determine the free vibration response, either by an initial shock produced on the tip of the sample, tested sample, or initial displacement at the same point. Here are the equations. My gosh. Here are the equations and values involved in this determination. And finally, the frequencies of free vibrations for different length values of the sample, tested sample, leads to a formula which is dependent of all the attached mass, of the dimensions of the sample, and this is very essential. This is a law that must be fulfilled by through the measurements, and we determine this coefficient C, and from C we evaluate the Young modulus value. This is the experimental setup for this is a sample, accelerometer, embedded system, electrodynamic vibration. If we use the sweeping frequency, but now at this stage, in this presentation, they are the initial conditions which are measured. This is a displacement imposed, and this is the force imposed. So the response of these two initial force or displacement, here are show the displacement, initial displacement imposed to the as the excitation of the sample, and for different length of samples. And this is the constant C measured. The points are the measured values, and the red one is the function which fit these results very well, because C is the same formula shown above. And from these C values, we determine the values of Young modulus. With that, These are the results obtained for different kind of text materials, biological materials we used for testing, and all of them, inclusive, included, including the wood, all of them have the same rule of variation against the length. And here are the coefficient C values, and here are the values of the Young modulus obtained for these examples. And the validation of the experimental results by using finite element method. Here is the beam with the coconut beam. This is illustrated for coconut beam modulus with the modulus of elasticity as, with a concentrated mass of 500 grams at the free top, density 900, and the traverse section with these dimensions. Experimentally measured values of vibration frequency, free vibration frequencies, and those calculated are pretty close, I would say, from an experimental point of view. So this method can be used with is very simple and reliable for determination of this constant. The other experimental testing is experimental testing for torsional vibration, which are produced by moment, massive moment, with initial angle of torsion. The same kind of mathematical modeling, but this in this case, the expression C is over L squared. So it's different from, this is the experimental setup. This is the experimental setup, and you see the details. And this is the Simulink model, which will validate the value of G for the E determined before, and of course by sweeping the value of Poisson coefficient, we get a closed book, closed loop, such that the values are consistent. These are some experimental data for G, and this is MATLAB simulating results, and these are experimental results. The value of coefficient of Poisson coefficient are modified until the frequency is very close that obtained by numerical analysis and with that obtained by experimental. Conclusions. You can see that, but what is, let's say, some future development where due to their simplicity and reliability, the presented method can be applied by manufacturers in the rapid development of composite materials. So they can test their production, which is not so constant in the quality and by random checking of different samples from the composite materials they produce, and they have some initial values of these frequencies, and therefore for the global values of the elastic and coefficients, transversal and longitudinal, so such as they can improve, modify the manufacturing process. Thank you for your attention.
Good, thank you so much. If you have questions, let us know. Otherwise, I made some adjustments in the schedule. So either in France they do not have access to internet, so it's exactly what I was doing now. I was just trying to fit the agenda so that we will not lose their seat in the schedule as well. So what I will do now, I will ask Rawan Abdullah if you can hear us. So if you are prepared to present the paper entitled Mathematical Modeling of Immune Dynamics in Chronic Myeloid Leukemia Therapy, Unrevealing Allergic Reactions and T-cell Subset Modulation by Imartinib. So the authors of this paper are Rawan Abdullah, Lawrence Fakir, and Andrei Halanai from Department of Mathematics and Informatics, University Polytechnica of Bucharest, and Irina Badralexi, Department of Mathematical Methods and Models, University Polytechnic of Bucharest as well. So please, Rawan, so you have 10 minutes or 12 minutes, and then conclusions. Okay, thank you.
Okay. So good afternoon, everyone. I'm delighted to have the opportunity to share with you my presentation. Okay, so do you see my presentation?
Yes.
Okay. So today we'll present the mathematical modeling of immune dynamics in chronic myeloid leukemia therapy, unraveling allergic reactions and T-cell subset modulation by imatinib. So the presentation will be divided into 4 parts. In the first part, we'll talk a brief introduction about mathematical modeling for CML therapy with imatinib, and then we will introduce the model and talking a brief summary about the equations. In the second part, we will move to some general properties of the solution. In part 3, we will dive into talking about stability of some equilibrium points, E1, E2, E3, and E4. And finally, in the final sections, we will introduce some numerical simulations and computations of the equilibrium points. First of all, chronic myeloid leukemia, which is CML, is caused by a fusion gene producing an abnormal tyrosine kinase protein, leading to uncontrolled leukemic proliferation. Imatinib, a targeted tyrosine kinase inhibitor, has revolutionized CML treatment by inhibiting this protein and improving patient outcomes. However, imatinib therapy can cause immune-related side effects, including allergic reactions, due to its impact on T helper cells, Th1 and Th2, and regularity T cells. Previous studies have primarily focused on modeling the direct effect of imatinib on leukemic cells using delay differential equations and earlier concepts of CML immune dynamics under the therapy. So below is a notable paper which studied the CML therapy using imatinib, but however, these studies offer limited explorations of its broader impact on immune system. To address this, we utilized this paper and added some equations to the model to account for allergic reactions, integrating the modulation of Th cell subsets and resulting a shift in the immune balance. Specifically, we will investigate the dominance of Th2 cells over Th1 and T regular cells, which hypothesized to contribute to the allergic manifestations observed during the therapy. Our study provides a comprehensive mathematical model to elucidate the interactions between imatinib, leukemic cells, and the immune system, revealing critical insights into the immune dynamics and aiding in the management of immune-related side effects during imatinib therapy. Now we will introduce the equations for our model. The first equation represents the concentrations of stem-like healthy cells, in which the beta alpha represent the self-renewal, which is the both daughter cells enter the stem-like hood, and the K alpha represent the differentiations, which is divided into symmetric and asymmetric division. The second equation represents the mature healthy cells. The third equation represents the concentrations of stem-like leukemic cells, in which the beta I and Ki are defined as in the first equations, and the last term stands for the mortality of cytotoxic T cells. Okay, so now for the fourth equation represents the concentration of mature leukemic cells, in which the last two terms, the last term represents the mortality during to cytotoxic T cells. Equation 5 represents the naive antigen presenting cells, in which C1 is the supply constant of supply, and C2 is the apoptosis rate, and the third and the fourth term represents the activation by antigen induced during the therapy with imatinib and leukemic cells respectively. Equation 6 represents the degradation rate. The first term represents the degradation rate, in which it is the degradation rate of mature antigen presenting cells, and the last term represents the activation by antigen induced during the therapy with imatinib. Equation 7 represents the activated antigen presenting cells by the leukemic cells, in which this is the natural degradation rate, and this is the degradation rate due to the activation by leukemic cell. Equation 8 represents the naive CD4 plus T cells, in which the first term represent the production rate and the final three terms represent the differentiation of these naive CD4 plus T cells into Th1, Th2, and T regular cells. Equation 9 represent the help Th1 cells, in which the first term represent the degradation rate and this term represent the differentiation of antigen present of CD4 plus T cells into Th1 cell. Equation 10 represent the Th2 cells, in which this is the degradation rate and this is the differentiation of CD4 plus T cells into Th1 into Th2 cells. Equation 11 represent the T regular cells, in which this is the degradation rate and this is the differentiation of naive CD4 plus T cells into T regular cells. X12, the 12 equations represent the naive CD8 plus cells, in which the first term represent the supply rate and this term represent the natural degradation and the maturation, and the final one, the maturation under the action of antigen presented cells activated by leukemic cells. Equation 13 represent the mature CD8 plus T cells, in which the first term represent the activation by antigen presenting cells, this one the suppression by T regular cells, and this is the suppression by leukemic cells, and the last two terms represent the stimulation of N1 cell divisions due to the positive growth signals induced by IL-2 secreted by both CD4 plus cells and CD8 plus mature cells. The final equation represents the amount of the imatinib pharmacodynamics, in which this is the absorption rate, this is the drug dose, and this is the amount, represent the amount, the final one represent the amount of drug in a plasma. Now, here are the equations that we talked about. Now, let's move to the second part, in which we will introduce some general property of the solution, which is the positivity of the solution. So for T to be the maximum of the delays, and by considering the space of piecewise continuous function, and for this initial data, we have the following proposition, in which for phi belong to the space of piecewise continuous function, and for initial data to be positive in this interval, then the solution of our Cauchy problem will be positive for all T in the domain of existence. Now let's move to the first equilibrium point, in which we will talk about the stability of it. The first equilibrium point corresponds to the death of the patient, in which this is the characteristics equation of it, and this is the stability conditions, in which we utilize this paper in order to study the stability of this equilibrium point and state these conditions. Now let's move to the second equilibrium points, in which the equilibrium points represent a healthy state with undetectable of leukemic cells and no allergic reactions. Here is the characteristic equation, and here in the characteristic equation we have the following equation, and these are the stability conditions for this equilibrium point. Now, in order to study the stability condition, here the first three conditions are easily studied. The fourth one, we should use the following reference in order to study the roots of P of lambda equals 0. So the conditions is this equation should have roots with no negative real part. In order to study this, we should start with the supposition that for tau 1 equal tau 2 equal to 0, the equation P of lambda is stable. Then the stability can be lost if and only if the root of this equation cross the imaginary axis from left to right as the delays varies. This can happen only if pure imaginary roots can appear as, so consider the following equation. So in order to analyze this equation, we will express P of IW in a trigonometric form and separate the real and the imaginary parts. And for this condition, by supposing T1 equal to 2 equal to 0, we will have this equation, and it's easily can see that it is stable if P1 and P2 are strictly positive. Now let's move to the third equilibrium point, in which represent the case in which we have a successful cure of with persistence of allergic reaction. Here is the characteristic equation And here is the stability conditions. We also have a P of lambda equation, which is already performed and studied in the stability of E2. And we have a new equation, which is the Q of lambda. And the condition on Q of lambda is to have also negative real parts. Q of lambda can be analyzed using the conditions 5, which parallel the approach taken from theorem 1 in the following reference. Now, let's move to the equilibrium point E4, in which it represents a successful cure without allergic reactions. The block triangular matrix of this equilibrium point is as follows. The conditions of stability are introduced here, in which the conditions also for stability are expressed and analyzed in the equilibrium point E2, and also can be used here to analyze the stability of E4. Now let's move to some numerical simulations and computations of our equilibrium points. For the first equilibrium point, the numerical study the numerical computation shows that the following condition is positive and the stability condition was to be negative. So in conclusion, condition does not hold, so E1 is not stable. The simulations of E1, here are some important variables which we will introduce their simulations, in which we can see that the Th1 cells, the simulation of Th1 dominate the Th2 cells dominate the Th1 cells, which means that in this case we have allergic reactions, and we can see that both healthy and leukemic cells decreases to 0. So this condition is the death of the patient, but it doesn't have allergic reactions, but it is not useful because the patient is with that condition. Now let's move to the second stability condition. Here are the stability conditions of E2, but the numerical computations shows that this conditions is not fulfilled because it is positive. So in conclusion, E2 is not stable. But let's move a little bit to the simulations of E2, in which we can see that the leukemic cells decreases to undetectable values, while the healthy cells attracted to a positive value. So we have a cure of the patient. Now let's look for the part of allergic reactions. As we can see that Th2 dominate Th1, so we have a cure of the patient, but with allergic reactions. Now let's move to the third equilibrium points, in which here are the conditions that we already stated for the stability of E3. The numerical computation shows that A99 is positive, which means that E3 is also unstable. But the numerical simulations can give us some informations in which the leukemic cells dies out. So we have cure of the patient, and the healthy cells attracted to a positive value. So we have a cure of the patient. And let's move to the allergic part. We can see that the Th2 cells dominate the Th1 cells. So we have a cure of the patient, but also with allergic reactions. Now let's move to the final equilibrium point, in which here are the stability conditions of the equilibrium point, but the numerical computation shows that A99 is positive, which should be negative. So we have instability of E4. For the numerical simulations, we have good news because it refers to the case in which the leukemic cells decreases to 0, but the healthy cells attracted to a positive value. So we have cure of the patient. Now let's move to the conditions, the allergic part. We can see that the Th1 cells dominate Th2 cells. So we have cure of the patient with no detectable of allergic reaction, so which is a good case of the patient. Thank you for your time, and I'm ready for your questions. I think you muted yourself. I can't hear. Now I can hear you.
I was giving some
point of view from my side, till if the public, if they will have questions for you or not. But from my point of view, I'm finding good and impressive results. So it is a good topic. So and evaluating all papers till now, I'm finding most interesting for myself. So congratulations for this work, Roman.
Thank you. Thank you.
Anyone questions live from online? Otherwise, I will skip to the next presenter. So, as I was mentioning, so we had some problems with colleagues from France. They told me that they do not have internet. So I found it useful that I can make a switch. So I'm taking one of the presenters that I know them, and I told him, just be there because I need that you will present, and so that I can save the time for France if they can figure out their issues with the internet. So now I'm inviting David Teodorionica from Transylvania University of Brasov. He will present innovative approaches in education with AI-powered virtual assistants. The authors of this work are, so as I mentioned, David Ionica, Ioana Corina Bogdan, Horia Alexandru Modran, all of us from Transylvania University. So, David, if you are online, please let us know.
I'm right here. Can you please tell me if you can hear me properly?
Yes, I can hear you. So we will need that you will share your PowerPoint slides.
Yeah, right away. Is everything in order?
So just a few seconds, and my colleague he will fix it. Okay. 2 seconds, 10 seconds, and he will solve it.
Just tell me if you can see my screen sharing.
Yes, now we can see it, and just zoom it, full screen,
Right.
and then 10 minutes your time. Thank you.
Wonderful. Thank you very much. As mentioned, my name is David, and today I want to present to you my work, which is some innovative approaches and a new way of helping students in their academical work. My project here does not have the intent to take the place of a teacher. It is quite a tool, and basically it has the meaning of helping students and teachers alike to be able to teach a certain subject in a more innovative way and interactive way in order to help the student to understand and learn the specific subject easier. Some key features that we will talk about today are some objectives of my work and of my application, some similar applications that are on the market right now or that exist in the world right now, and I will tell you what is different and where is my project coming with something new. The model and the way I have thought and built this virtual assistant, some technical and social solutions, the current status of my work, and some further implementations that I plan on modifying and adding in the near future. So, the objectives of my work are pretty straightforward. It is a virtual assistant with the goal of simplifying the learning process of a subject in an interactive manner by providing analogies and exercise examples tailored to a specific topic. For example, since I'm studying telecommunications at my faculty, it is a good starting point to help students learn about antennas and learn about physics in a more interactive manner. And that's where my virtual assistant will come in handy to help with examples, to help with providing analogies, to provide exercises and many sort of applications in order for you to be able to study the subject easier. And also occasional quizzes or some checkups to see the progress that the student had made throughout a month or throughout a semester when it comes to actively studying a subject. And based on that, because it will be each user, each student will have their own profile, the AI will be able to develop a psychological profile so that it can adapt efficiently to the user's aptitudes and also to ensure a personalized and optimized interaction. Now, some similar applications when it comes to the virtual assistants that you may have heard before, we may have heard about before are Alexa, Siri, Bixby, Cortana, Weebot, and Replica. These are some of the most popular virtual assistants that are that exist right now, and each one of their own has their unique features that they are providing. And that's where my virtual assistant comes with its own model and with its own persona, because the interaction with students is improved in order is to improve their academic performance and their professional development, and also engages in digital interaction throughout vocal interactions. Basically, you don't need to write each message or each prompt. You can simply ask the question, and the virtual assistant will just answer to what you have told him. The response is received throughout an audio signal and also a text prompt. So, if you don't understand the audio, or if you don't understand the message exactly, you have the text as well that you can read, and you can see exactly what the answer to your question was. And it can also be an area where this project can go is that it can take a step further into the humanoid robots, and in this way we can train humanoid robots to be trained to imitate human behavior doing certain interactions, and the virtual assistants can be integrated into the humanoid robots such as like PKD, Eve, Sophia, Emeka, and so forth, so on. My technical solution that I have found and that we have thought about when designing this application, this project, is that the assistance in understanding subjects from pre-university or university education, as well as improving academic performance by generating explanations and exercises, verification of knowledge, as I mentioned before, through tests and quizzes at the end of a lesson or at the end of a time frame. It depends on how is the subject structured. And also feedback based on results to provide a positive outlook on the situation, adapted to the user's psychological profile, level of education, and academic preparation. Because the students that are from pre-university fields will have a different approach than the ones that are already in a university education. And also strategies and learning plans to improve information retention, suggestions, and best practices in order to learn and to better store your information on the subject. For the social solutions, as previously mentioned, the main advantage of this VA is that the user can speak directly to the assistant, giving the impression of an interaction as close as possible to that of a teacher or a human mentor. And its goal is to help adolescents or young people suffering from social anxiety, or who are sure to have a useful solution that can offer them the opportunity to improve their academic performance. Subsequently, they can be guided towards seeking specialized help if needed in extreme cases where based on a list of features or on a list of symptoms if the VA thinks that a more specialized or a more direct approach from um, a specialized unit is needed, it will suggest so. And the current status of our application, as mentioned at the beginning, is that in the current version, the vocal communication between humans and the machine is possible for the purpose of asking trivia questions using the GPT-4 engine to generate responses, which are also provided as an audio output throughout the user's output devices. That's a short representation of how is the application thought and the process behind all the functions and everything that we have wrote so far. And lastly, some further implementations that we are currently thinking and working on. The most important one is to upgrade to the newer GPT-4o engine to generate responses with a greater accuracy in a shorter time. I want to create a new and modern and more visually appealing graphical interface. The one that we are currently using is an alpha version that isn't the most eye appealing one, and that's why I want to modernize it and make it much better. And in order to have access to subjects and to materials that the response can be generated from, it will have access to a database specific to the fields of cybersecurity and telecommunications specialization for now, and with the possibility of extensions to different and other topics, other subjects, and other fields. And last but not least, the generation of short and concise audio responses with detailed explanations, including diagrams, equations, and syntaxes, implementation of a text box that the VA can read on the user's command. Because in case that the answer is too long or too complicated to generate, to avoid a very long audio cue that can be not pleasing, or that can create a bad situation. You have a shorter and concise response when it comes to the audio response, and in the text box you'll have the detailed version of the whole answer with diagrams, equations, and syntaxes, and also you'll be able to command the assistant to read them out for you, the whole answer or just a part of it. Depends on what you want to understand or what you want to explain further. And lastly, these are the bibliographic references that we have included and that we had used when we created our project and when we discussed about this whole article. And that will be our project and the state that we are currently in right now.
Okay, thank you so much, David. So if we have questions from the room or for those who are online, okay, yes. Maybe 3 seconds. You will have a question.
No worries.
Can you hear me?
Yep, I do.
Okay, so you said this virtual assistant is for students with anxiety or that are shy in this current version. But do you think that using your model or your interpretation, it could be used to replace the human component in education?
I don't think so. It will be able to replace the human component as a whole, because it still needs teachers and materials in order to be able to generate its answers, and it still needs a database, and the best way to access it and the best materials are from teachers that are already teaching the subjects. So that's why I wanted to implement it as an extra tool, as something that you can use to further help you with with the studying. Since the question was about students that are shy or have social anxiety, it's because many students feel like some questions are too basic or some questions are not are too easy to ask, and they decide not to ask them. So that's why here's where my VA comes in, because you can ask it any kind of question and you will receive your answer in the best way possible, in the best way it can generate it.
Okay, thank you.
No problem. Thank you very much for the question.
Questions? Okay, so that's cool. So otherwise, if we do not have other questions, thank you so much for this presentation, David. And
Thank you for
have a nice,
your time and for having me.
okay. Now I think I need to give a response to Maxim Bogdan. So we had an issue with the connection with France. So I found it that I can switch to presentation so that I can keep the presentation from France instead of David. So now we will take, normally we should take 30 minutes break, and then we will start as normal as is given in the program.
So I will come back after 30 minutes.
Yes, please. So normally you are scheduled at 5:15.
Yes.
So 30 minutes. There is one presentation, Mohammed Gezar. I think I saw his name. If he's not there, then we will skip with the next presentation. Okay, so just make sure that everyone is online, and if something is missing, then we continue with the next presentation.
Okay, okay, thank you.
Thank you for your understanding, and all of you for your understanding. Okay? Okay, so 30 minutes coffee break, and then we will be back in the same room and virtual room. Thank you.
Thank you.
Hello again. My name is Luciana Morogan and I'm from the Military Technical Academy, and I will be your guest for now on until the end of this day. So, shall we continue? Is everyone online ready? Normally, the first paper from this subsection, it's on the stability of 2D General Rosen-Lyapunov systems by Mohamed Ghezar, Jilali Bouagada, Kamel Beniatou, Mohamed Chadli, and Paul Van Duren. If you are online, do you hear me? You are there? We can wait a bit. Do you hear me?
Is here.
Yeah? Okay. When you're ready, you can start, please. Kamel, do you hear us?
Normally, Professor Ghazar is here. I will call him.
I don't know who is going to present from your side.
Professor Ghazar.
Okay, we are waiting. Professor Ghezar, do you hear us? Okay, I understand that Professor Ghezar doesn't hear us. Kamel, can you present the paper, please? Kamel?
We have agent. We can pass to David, and then we return to Professor Ghazar if it's possible.
Can you repeat that, please? To pass to what? To the next paper or to one of your colleagues?
We can move. He tell me we can move to Bogdan.
Oh, okay. Okay, and we'll let you to prepare. Okay, no problem.
Yes.
Bogdan Maxim, are you there?
Yes.
Okay.
Can you hear me well?
Yes, loud and clear. Thank you. So we have Bogdan Maxim with the paper entitled The Fisher Type Evolution
Can you
Equation.
hear me?
Yes, we do. Do you hear us? Bogdan? We see only your eyes.
This is my paper. It can be seen?
Yeah. So let me present your paper. It's a
Oh,
the Fisher type evolution equation of the application.
I'm a PhD student from Craiova. I stay in Iași, but I'm at University of Craiova, and my subject today is the application of partial differential equations in image processing. And I wanted to do something in applied mathematics. So I choose the Fisher equation. It is like that, an evolutionary equation, because it has some great features, like global boundedness, which means that if U0, this will be an image, the starting image, it will be a number, a matrix when discretized, with entries from the interval 0, 1. So if I made this, if I simulate this equation starting from this image U0, I want to be sure that my solution in time will be still in the interval 0 to 1, where 0 will be like black and 1 will be white in the image. I spoke about grayscale images there. And this is a feature that Fisher equation has. This is my equation starting with an image, and I want to do something, some effects or something like that, starting from an image. What I succeeded to do, I start with this image, the cameraman. It is used by many researchers in image processing. I start with this image and I try to do some things like making it disappear in a diffusion-like way. Another thing that I do is to deform this image, the cameraman, into a house, into the house, but with diffusion, not just a simple linear transformation between those images. So not pixel by pixel transform. I transform the pixel here to the pixel there. No, it is not like this. It is more enhanced. So transforming an image to another, I can do this with this Fisher equation, making an image to disappear and deforming an image to the mathematical solution of some PDE. This is interesting for seeing how the differential operators act on an image. This is nice to see. To do this, I work with weak assumptions, weak formulations of PDEs, and the most famous result here are the weak maximum or minimum principles for elliptic and parabolic problems. This is the weak principle for elliptic equations. So if you have minus Laplacian of u plus c of x times u greater than 0 and the normal derivative of u greater than 0, then we can say that u is positive on omega, or this is the second part, but it will not happen in our cases. The parabolic minimum principle is similar. The conclusion is the same. You can conclude that the solution is positive if the two inequalities are satisfied in a weak sense, which means that this integral inequality is true for any phi in the Sobolev space H1. These are the basic tools, the most used tools in my article. I defined what do I mean by a solution for my initial problem. So this will be the definition. Simply multiply by phi the initial equation 1. This is by phi, and then integrate, and you reach to this variational formulation in terms of phi. I have to recall some facts from linear for the linear case, because here we have a non-linear term. It is a quadratic term, but we will solve this non-linearity by appealing to linearity as well. If we have such a linear equation, basic parabolic equation, then we have some very interesting results. The first is well known. If the initial data is from L infinity, which means that it is bounded, then the solution is bounded at any instance of time, and this is the superior bound. So it is bounded by the infinity norm of the initial data and the infinity norm of the source in the right-hand side. I have other results there. This is what I found by myself. The 4, especially the result at 4, which says more than the positivity of the solution. It is some kind of strong positivity. So it means that, I mean, at 4, if we have an initial data on L2, so it can be unbounded, but not to be 0, to be positive. This plus means positive, but not 0. And the source term f is positive, then the essential infimum of the solution is greater than 0. So our solution is above 0 at any point in omega, all the time, starting from any time close to 0, because initially it can be unbounded, but then after a very little time, the solution becomes strictly positive everywhere. So it departs from 0. This is the result I found, and the methods I used there are some borrowed from functional analysis. I used the concept of almost interior point, which was introduced recently in this year by Johann Gluck and Martin Weber. I communicate with them to show my result. This is their result, which means that if you have some point in a space and it is transformed in an almost interior point of the other space, then all the almost interior points of the first space becomes interior points of the second space. This is what I use here. Almost interior points of L infinity are those functions with essential infimum greater than 0. And almost interior points of L2 are a little different. They are any positive functions that integrated with L2 norm or by the Hilbert product on L2 with other positive function is positive, strictly positive. They're kind of different, but in this case, they match very well L2 with L infinity. The next thing I have, if we come back to the problem that I study, I have the guarantee from the weak minimum principle that if I start with an image and I deform it with this PDE, I remain with an image. So U remains between 0 and 1. And I have even better bounds. R over P, this is from the assumption I have. This is an important assumption. This guarantee that our solution U stays between 0 and 1, that P is greater than R. This is very important fact. So we have an upper bound and a lower bound for U. I have to prove the existence and the uniqueness of the solution for this equation, and this is done by a classical method. They are called monotone methods. We define this operator f, capital F, which assigned to any function u, or to any image, if you want, another image that is the solution to this equation, which looks like more like what we have there. If we find a fixed point of the operator f, then we are done. This will be a solution to our initial equation. This lambda here plays an important role because it makes this function to be monotone, an increasing monotone function in U. So we can apply monotone methods. This is one of the main results. Our problem has a unique solution. The solution is obtained recursively by starting with 1, which is like the whole image is white, and do these iterations. we get to another image and then to another, and to another until it stabilizes to fixed image U. And passing to the limit this recurrence, we'll have that f of u equals u, which means that u is the solution to our problem. And uniqueness follows with ease from the minimum principle. The interesting part comes now because our parabolic equation 1 also has some steady states. So when t goes to infinity, when the time goes to infinity, I will prove that my image will be closer and closer to the solution of this equation, which is an elliptic equation. The t terms disappear from here. The Neumann condition remains, and I put the condition u to be positive so that it will make sense. Negative. This equation can have also a nodal solution, which means that they can change sign, but we are not interested in such solutions. It is trivial to remark that 0 is a solution to this equation. If you put u equals 0, then we are done. But this will be called the trivial solution. And another main result is that this equation, this elliptic equation, has a unique, strictly positive solution. A unique, so this is very important, and strictly positive. So it is not just a white or a black image. Now we need to show that our solution, small u, tends to capital U as t goes to infinity. So we need an asymptotic behavior for u. And as usual, the stability can be obtained by some eigenvalue problems, considering some eigenvalue problems, and applying Krein-Rootman's theorem, which assures that this is the linearized version of our equation, of our nonlinear equation. This 2p comes from the derivative of u squared, which is 2 times u. We have here u also. So it is a linearized version of our equation. And from Krein-Rootman theorem, we know that this equation has a strictly positive solution, exactly 1, for its principal eigenvalue, which is the smallest. And it can be computed via Rayleigh-Ritz cotient, which is here. The main result about the asymptotic behavior is this one. So we have that, but only if the principal eigenvalue is positive, and I provide here a situation when it is. It is easy to remark that in such a case. If the principal eigenvalue is positive, then we have that our solution is approaching the steady state, and it's approaching it very quickly because we have here a negative exponential. So as t goes to infinity, this is kind of e to the minus t. So it is very quickly convergent to 0, this difference, which means that the image as t grows become the steady state image. This is very important in what I want to do to transform an image into another. And these constants here do not depend on the initial image that we start. So the speed is guaranteed no matter with what image you start. This is the same speed, so very quickly. Now we come to applications. We have an initial image u0 and the final image u, and I want to transform u0 to u using this Fisher equation, from what I said, we expect that small u will become as big U for large enough T. Now, if we
Do you
choose
hear me,
some
Bogdan?
special P,
Bogdan,
and if
sorry.
I just take P from this equation, if I extract P from this equation, this is what I will find. This is the formula for it. The only thing I have to take here is P to be greater than R, so that our results are true. But U is less than 1, so R over U is bigger than R. So the first part of P is bigger than R. And the second part can be make as small as we want by taking this constant as large as needed.
Bogdan,
So
excuse me, do you hear me?
Yes, I hear you.
You must somehow hurry up.
Yes,
Best.
I finish.
Okay, thank you.
These are my last things. Then are
Okay,
pictures.
okay, sure.
With this P, I make videos and images with an algorithm written in MATLAB, very easy algorithm, just finite differences. And I obtain something like this. So I want to transform the cameraman into the house. And choosing some kind of effect, I choose some sine, cosines. There is some diffusion of the first image into the second one. And in 200 iteration, we have from this to this. We reached from this to this. Another effect is the dotted effect. Somehow the same image becomes the house, but in another way. In my article, I show other things, other effects. How can I make an image to disappear? Something like this. Just putting the second image to be completely white and apply the same thing. And it disappears in 200 iterations. And to transform an image into a mathematical solution of some equation, if you take that P to be not an image, but a mathematical function. Thank you for your attention. That's pretty much it.
Thank you.
Thank you.
Thank you.
If you have any questions from Bogdan, for Bogdan. Okay, Bogdan, so no questions for you. Thank you once again.
Thank you.
And now the next paper, it's the paper from a few minutes ago.
Professor Ghazar.
Yeah, do you hear us, right?
Hello, do you hear me?
Yes, we do, finally, yeah.
Excuse me for my, I had some troubles with my PC. You know, I have to change the PC, and now I'm okay. I'm ready if I can.
No problem. We are waiting for you. So the next paper, it's on the stability of 2D general Rosen-Lyapunov systems. Professor,
I don't know if if my screen is clear.
Yes, it's clear. Yes, it's clear.
Yeah, we do.
So first, I want to thank chairman and assistants for their presence here, and I'm happy to be a part of your workshop. It's the second time, and so my presentation will be about stability of 2D general Rosa-Lyapunov system. Some systems called the Lyapunov system appear in compartmental systems, and it's really difficult to us to solve and to deal with the stability behavior. And our work have to give us a supply for this axe of research, and this work is a joint work with my colleagues Dr. Benito, Dr. Professor Bouagada from NHSM, National Higher School of Mathematics, and Professor Chedli from the Paris-Saclay University, and Paul van Duran from the Leuven University of in Belgium. So before we state some introduction for those systems. So those systems appears in 70s and 1790s from Giovanni and Rosa. They give us fundamental statements for those systems. They give us some definitions, some fundamentals for those systems who appears in the physics and the chemical phenomena. And generally, those systems are deal with two variables. So two variables or three or n variables. My aim work is the bidimensional system, which were studied first by Tadeusz Kazorek in the 70s and 90s, from Tadeusz Kazorek from the Polish Academy. And after there will be many results concerning those systems. Before I will state with some results concerning and the tools which were applied for our work. It's a lot about the chronicle products and some properties of this chronicle products, and I will define the general 2D system by the Formula 5. As you can see, those systems have particular notations and particular form. Really, it's not easy to deal with those bidimensional systems. In our work, we studied the which is called the general 2D system. As you can see in the Formula 5, the unknown system X is at the right and left of the form, and it's really difficult to us to deal with this. The idea of the work is to transform or to convert this Lyapunov system. It's by the way, it's called Lyapunov system because it seems like the Lyapunov function. When we studied the stability test of Lyapunov system, we have the same formula, and those system was called Lyapunov system. And generally, this system were found in the compartmental system in electronics and automatism. Those system for the solution and for the positivity test or positivity condition were really too difficult to have the solution. Then we have to transform this system into a standard system using the chronicle product. This system 5, after using the chronicle system, we can transform this system into a standard system by the form Ex point equal to Ax plus Bu. Generally, the system. For our work, we work with this appears in the control theory and system theory, and we have the form in the by the formula 6. Donc now to study the stability behavior of the formula 5, we have to study the stability test. Do you hear me? Hello, do you hear me?
Yes, yes.
Okay, but we have to now to study the stability test of the formula of the system number 6. That system is defined by the formula 6 with appropriate matrices and appropriate dimensions. Donc, to study the stability test, we have just to study the stability of the autonomous system, where UEG equal to 0. By the way, I forget to mention something. This work deals with two type of bidimensional system. Called the bidimensional system discrete time. In the discrete time, with two discrete variables I and G, and the work also deals with the call it the hybrid system with the
Not
first
exposes matrix and Prometheus server full matrix.
formula 6.
Full matrix to get it from the not exported.
Hello. So I repeat, the systems. We have two type of systems called discrete time systems and hybrid time systems, with the first variable is the time or the continuous variable, and the second one is the discrete time variables. There's a third type of systems called the continuous system, with two continuous variable T1 and T2, but those were not until now were not studied. Donc, in our work, we studied the two type, and here I'm here just to expose the first type of them. So, for the autonomous system, defined by the formula 12, call it this autonomous system, we have this definition 5, which characterizes the stability, asymptotic stability of this system by the formula 13. For our work, we have used the characteristic polynomial defined by 15 and 19, and in the 19 and 15 by the formula for 14 and 15. We have to know that here we are studying the stability not by the spectral approach, but by the LMISC approach. LMISC means linear matricial inequalities. There's we have not the same as the Lyapunov test, but we have the same approach. For that, we use some theorems and definitions from the Kaczorek and Rosser works, like in theorem 6 and theorem 7. And also we use with we deal with theorem 8 which use the so-called matricial polynomial or polynomial matrices. It's just polynomials with coefficient with matrices coefficient. Theorem 8 states that Hermitian polynomial matrices in the form PZ equal to sum. This sum is positive definite if there is a Hermitian matrix such that formula 19. We have to know that this theorem 8 from Jena and al. With the help of Professor Paul van Doren. We have just a particular case in the sense of we have two dimensions. In Jena and al, we have the generalization. But here, some works and for our work, we have just to deal with the bidimensional bidimensional case. Our first aim result states that this our general 2D Lyapunov system is asymptotically stable if there is Hermitian matrices x1, x2, x3, which where the LMEs 20 and 21 are feasible in terms that they are solvable, have solutions. The proof we started by the spectral study and use some definitions and we have to and some algebraic definitions and properties, and we have to know that generally LME's condition or LME test is more effective than the spectral test, because we have to deal with matrices which are really very big with large dimensions, and the LME's test in terms of complexity give us a solution and feasibility in less than 2n square 2 times 2n square 2 operations. We can give you a numerical example. If we have this numerical example for E and A0 and A1 definite like this, we can state that this system is feasible, okay, and the system is asymptotically stable. We have to know that this work was published in 2020 in the Romanian Academy in Journal Mathematica for the both cases for the discrete time and the hybrid time systems. Second example for E and A0 and A1, we have the stability test, and it confirms that the system is stable. In conclusion, sufficient conditions for 3D general Lyapunov systems are derived to guarantee asymptotic stability. We have developed new test of stability up to the discrete and continuous time. In our presentation, we have just presented the discrete time case. An LME approach is then described, and the case all obtained are in terms of LMEs and have at most dimension of 2n squared times 2n squared. As a perspective of work, the continuous case when we have two variables T1, T2, were until now not being exploded because it's really difficult in terms of the LMEs. We have to state that the solution X1, X2, and X3 are matrices, are definite positive, definite matrices, and until now we can't state or solve or give an LME test for this system. Thank you for your attention, and really I'm here to give more information. Thank you.
Thank you. Thank you.
Thank you.
And excuse me, just to say, excuse me for my bad English. We are francophone, and
It was okay. We understood what you said. Yeah. If there
thank
are
you.
any questions from the audience, we do not have any questions. Thank you once again, Professor Ghezar.
Thank you for you. Thank you very much.
Thank you. Thank you.
The next paper, we have Kamel Beniatou and Jalib Bouagada on the admissibility of fractional singular continuous time systems using Kaputa derivative, an NMI approach. Are you online? Are you with us?
Yes.
Okay, so you can take the floor.
Presentation is clear?
Yes, it is.
Yes. Thank you.
Thank you.
I'm Dr. Kemal Benito, a specialist in control theory and dynamical system from the National Higher School of Mathematics in Algeria. It's an honor for me to be here for the third time for this conference, and I would like to extend my sincere thanks to the organizer for this wonderful opportunity and their continuous dedication in making this event a success. This work is presented by myself and Professor Jilali Bouagada from University Abdelhamid ibn Badis of Mostarana. First, my title is on the admissibility of the fractional singular continuous time system using Caputo derivative as a fractional derivative and an LME approach for as a test for stability and admissibility. First, we present some introduction and some preliminaries and stability and admissibility condition, and then numerical example and simulation. And we conclude our work by a general conclusion and some bibliography. First of all, there has been in recent decades and years a significant attention and among interest in the system and the two-dimensional system that has garnered attention from numerous researchers. The appeal of this class of system lies in its potential of diverse and to explain more applications such as modern circuit design, digital image, and signal processing, mechanic, physics, and medical application. From the most using model in the case of two-dimensional system, we have two cases: Fornazini-Marchesini model and the Roser model. In this case, in this presentation, we will introduce the general case of singular Roser model. These models are introduced by Giovanni Roser in the 1970-1980, and they have shown many applications of this model. One characteristic of this model is that this model propagates state into the independent direction. The first is horizontal axis, and second in the vertical axis. From the most test of in control theory or dynamical system is the stability analysis or the stability concept. The stability analysis or concept for this class of model have been treated and introduced by several authors like Yuri, Sijlak, Professor Kazorak, Professor Bouagada, Paul Van Doren, and many others. In this contribution, we investigate. Our aim is to investigate admissibility of two-dimensional fractional singular time system which are described by the Roser model. In this part, first part, we will introduce to recall the Kronecker product as a products matricum, which denoted by this notation, and we denote this notation by we multiplied each coefficient of or each term of the matrix A by the matrix B. The second definition is a basic definition for the gamma Euler in fractional calculus. And in the following, we denote for simplicity and notation, we will denote the expression A plus I transpose of this matrix A by sim A for our needed. Secondly, we present this new fractional derivative as in general. In reality, this is a general derivative for a 2D continuous function xt1, xt2, which depend in two variable t1 and t2, which are continuous variable. Is defined by the partial derivative is defined by the following formula. And now we present the general 2D singular continuous time model described by the Roser model. In this step in this paper or in this presentation, we consider E is a singular matrix. A is the state matrix. X ht1, xv t1, t2 are the state space vector horizontal in the horizontal cases and the vertical direction. Bi, bh, bv are the control matrix. ut1, t1 is the control vector of our system. For our needed, we define some new definition as spectral abscissa for general system, which defined by the equation or the relation tree, and a new set of function or matrix which defined by the gamma s1 power alpha, s2 power alpha. It is the determinant of the new matrix k alpha b e moins a, knowing that k alpha b is defined by the following matrix. For our need and to treat or to introduce and this class of model, we have to consider an enforced system. It means in this case we take ut1, t2 it equals 0 to treat and to analyze the stability condition. Is the first step. To study this concept, we have to introduce some definition and notion. The system defined by the equation 6 is said to be regular if there exists a unique solution xh t1 t2 and xv t1 t2 for any given initial condition xa xh0 and xv t1 0. Knowing that this initial condition must be bounded. Therefore, the following result give a necessary and sufficient condition of regularity. The system defined by the equation 6 is regular if and only if the determinant of all these matrices is different to 0 for some SE in the complex plane, or which can also written in the form defined by the equation 8. Another definition, the system 6 is said to be impulse free if and only if it's regular, the one condition, and the degrees of determinant is equal the rank of the singular matrix E. And then in the following, we introduce the notion of asymptotic stability of a 2D system, which is described by the equation 6. First, we present a basic definition and the main definition of asymptotic stability. This fractional singular system is called the asymptotic star if and only if the limit of the norm of the solution when T1 and T2 go to plus infinity must be equal 0 with a boundary condition the sub of xh02 and xv T1 0. And then based on the work in the following reference 2, 3, and 22, we can deduce the following lemma to help us in our main theorem. The characteristic polynomial of the system is defined by the following equation, equation 11. This is just a reformulation of the last reformulation. This is the basic lemma. The model described by the equation is said to be star if this relation is satisfied, which mean the spectra EA denote the set of the finite mode of the pair E and A, which is equal to the determinant of K power alpha B E minus A. This inequality, the equality 12 mean that the argument of the first variable S1 power alpha is strictly greater than alpha P over 2, and argument of S2 power beta is strictly greater than beta multiplied by P over 2. And to achieve our condition, or to give a general definition of admissibility, we now introduced this concept. The system 6 is described or described by the equation 6 is said to be admissible if the pair E and A satisfy the three conditions. It means that these pairs are regular, impulse-free, and asymptotically star. This is the general definition. But now we have to move or how we can say that the system is admissible. This theorem is our main contribution in this past. Can you hear me? Do you hear me? Thank you. The system 6 is said to be admissible if and only if there exists a matrix, a positive defined matrix X, and a Y matrix verifying or satisfying the three conditions. The inequality 15, the inequality, the LME, it's mean the eigenvalue of this matrix are negative defined. And also the equation, the inequality 16, and the two inequality 17 and 18. With this new matrix, or theta and A and E. This mean this block the theta 11 and theta 22 depend on the alpha and the cosinus and sinus of this value. As an approach, or as we do in a survival paper, or a presentation, we present an practical problem with the circuit RSA problem, which are the general solution of this problem has been discussed by Professor Kazorak and Rogoski in 2015, perhaps, which represent a long transmission line with the distributed element. This example is shown with the following figure. For the considered circuit in the last figure, the reformulation of equation would describe the current and voltage in this line as a function of time t and space variable x. The variation of this voltage and electricity in this line is described by the following system. Equation 21 can take the form of the following system equation. It means we have transformed this equation, these two equations, on an equivalent Roser model. This model is described by the equation 22. We can see here that this system is singular because the determinant of this matrix is equal 0. We have we have the state matrix and the two state space vector x h t1 t2, which represent u x t, and the voltage the electricity voltage e I x t. For some value, for some given value of some parameter R and C and G and L, we consider and for a given for introduced control UT1 UT2, our system in this example we can rewrite it in the following or equation 23 with the following matrix E and A and now applying our definition and our main theorem, we can see that this system is really admissible. Why? Because we have found the proposed solution or a feasible solution or of our main theorem X. We can see that this matrix is positive definite and a new vector or a new matrix Y. As a conclusion, in this paper, we have presented sufficient and necessary condition of stability and admissibility for a 2D general singular fractional Roser model, which is described by the Caputo derivative, a new approach based on three type and in by three steps: the Kronecker product, the characteristic polynomial, and the concept of linear matrix inequality, which is a powerful tool to treat or to analyze this type of problem. All this problem or all these results are simulated and illustrated by a numerical example of an electrical circuit application to show the effectiveness and applicability of our method. Here some bibliographic or reference. The main references are based on the work of Professor Kazor from Poland.
Okay, Kamil, thank you. Do you
Thank
hear me? Yeah? Do you hear
And
me?
thank you, Professor. Thank you for your attention.
Thank you too. Do you hear us?
Yes.
Okay, thank you, thank you. If there are any questions from the audience? No, they're not. Okay, so thank you, Kamil. And the next paper, that we were waiting for some time, comes from France, from Doué Denguir and Latifa Bouta Badas, with implementation of an efficient supervision system for LoRa gateways in farm environments. Are you hearing us?
Yes, I'm here.
Okay, so you can have the floor.
Okay, so hello everybody. I hope you're doing well. So my name is Dua Denguir, and I'm from the University of Lorraine in the second year. I'm currently a student in the second year of Bachelor of Electrical Engineering and Computer Studies, Electronics and Embedded Systems. So in the University of Lorraine, in the institution of Henri Poincaré Longwy. So I'm here today in order to present to you the project that I worked on during my internship, which is about implementation of an efficient supervision system for LoRa gateways in farm environment in the company Azura Group. So let's talk about the context. In recent years, the Internet of Things has been a thriving field for research and development. The future of IoT has the potential to be limitless, and by 2025, it is estimated that there will be more than 21 billion IoT devices. So Azura, a leading agriculture company where I did my internship, runs over than 50 farms with sensors collecting vital data essential for optimizing agriculture process. So using LoRa, so LoRa in the gateways, this data goes to gateways across farms. Our project or my project ensures these gateways work smoothly, crucial for collecting and analyzing data, and we monitor server resources and gateways connectivity to ensure Azure IoT systems run smoothly. So here is like a plan that I'm gonna follow for presenting my project. Firstly, I'm gonna talk about the objectives of this project, and then I'm gonna explain what is the LoRa gateway and the presentation of the monitoring tools used during my project, and the final solution with the Prometheus, Node Exporter, and Grafana. This is like the tools that I used. And of course, I'm gonna conclude my presentation with a small conclusion and perspectives for the project. So talking about the project of the objectives, so the main objective of the project is to create like dashboards with panels showing the different measurement of a LoRa gateway. Talking about the measurement of LoRa gateways, I talk about the CPU, for example, utilization and the memory, and of course, with ensuring that I'm gonna monitor the connectivity of this LoRa gateway to the internet and to the network. And then there is another objective, which is creating alert system, ensuring timely notification of any anomalies or critical events by email. So this is the two objectives of my project. So talking about the LoRa gateway, this is the little presentation of the LoRa gateway. So it's like there is a lot of component of the LoRa gateway. The main component, there is the end nodes. The end nodes, if we talk about the end nodes, we talk about the sensors in the farms. And it is like IoT devices with LoRa modules transmit data wirelessly over long distances using low power. So for example, our sensors in the farm, like humidity sensor, temperature sensor. So we're gonna transmit this, the different measurement collected by the sensors in the farm to the gateway. The gateway, there is like 3 steps to process the data collected by the end nodes. There is the first step, which is reception, listens for and receives signals from multiple nodes, so from our sensors in the farm. And then there is the step of demodulation, converts received LoRa signals into digital data. And then, of course, the last step is forwarding. Forwarding means sending this data to a network server via Ethernet, Wi-Fi, or cellular connection. And here is our network server. So the network server, what it do? It's like they manage. The first step is processing. It manages and process data, ensuring security and deduplication. And then this network server, after processing the data, it sends it to it sends this data to application servers for the use. For example, a data analyze can get this data in the application server. For example, the platform open source like Thinkboard and Grafana, for example, it's like platforms for monitoring this different measurements or the metrics received by the gateway and sent by network server. And then I'm going now to present the different tools that I used during this project to ensure achieving the goals of the project. So firstly, I used like the trio TIG, Telegraph, InfluxDB, and Grafana. Telegraph is like a collector, a collector of different metrics like CPU utilization and for example memory, and then the data collected by Telegraph, it's going to stock in InfluxDB. InfluxDB is like a database. We're gonna stock the data collected by Telegraph. And then Grafana is like an open source platform of visualization where we're gonna create dashboards to see or to show the different measurement of the LoRa gateway, and or also we're gonna show if it is connected to internet or no, or if it is connected to network or no. This is like a first solution of, or it's like a first model of monitoring that I used in the first of my project, but it doesn't literally work because of like compatibility with the gateway, the LoRa gateways. That's why I looked for another solution, which is the using of node exporter and Prometheus and Grafana. Of course, Prometheus, Grafana, and node exporters are commonly used together for monitoring. These tools specifically provide node and context statistics for monitoring Linux systems. And then for explaining my idea of the project, how it's gonna work, how we're going to ensure this visualization, here is this illustration. So this is the illustration or this figure illustrates the core concepts and tools that I used in the project, and each gateway is essentially and you should know that each gateway is essentially a Raspberry Pi. What is a Raspberry Pi? A Raspberry Pi is like a server, is like a compact computer, or we're gonna say it's the brain of a LoRa gateway that is going to process the different data collected by the sensors. So at the core of the setup of the Prometheus server, so here is like a Prometheus server that, so in a Raspberry Pi server, we're gonna download Prometheus hosted on a Raspberry Pi in the Office network, and then Prometheus serves as an open source metrics database and monitoring system. So Prometheus, we can say that it's an open source metrics database. It's like it get the
We don't hear you anymore. Do you hear us?
No, you can hear.
I believe we lost them.
Perhaps she have a problem.
Maybe.
Because
Do you hear us?
was leaving the
It seems like she froze.
yes.
Due?
That's it's return.
hello.
Yeah. You're online. Do you hear us?
Yes. What about you? Do you hear me?
Yes, we do. What happened?
Yes, now yes.
Okay. Okay. So, did you hear me when I started explaining this?
Yes, we do. We did. We did, but
Okay.
please try to go to conclusions faster.
Okay. So
Try to summarize your ideas because it's kind of late and we are a bit in some.
okay. Wait a minute.
Do you hear us? Do you freeze again?
Yes. Yes. I hear
Yes,
you.
you are there. Okay, so please be short. Okay. Thank you.
Okay. Yes. Yes. Of course. So I said so this is the idea of monitoring system that I download or I created for monitoring the different LoRa gateways in the farms. And then I'm going to talk about the black exporter like another tool to use for ensuring the connectivity to network and the connectivity to internet. For example, a black box exporter uses the protocol of communication ISIM for ensuring connectivity to network, and the HTTP protocol used by black box exporter to ensure the internet connectivity monitoring. And then here is some results. For example, here we have the different LoRa gateway. For example, this LoRa gateway TGPT, for example, the state is up. That means it is connected, and this it is connected to the internet and the network. And then this is the alert manager, another tool to use for creating and generating alert manager to receive notifications in the mails in Gmail. And then here is like an example of an alert. There is another example on the phone. For example, there is like instance down of this LoRa gateway and on laptop. And then on the interface of Grafana, I created like a dashboard showing different measurement system, for example, load, RAM used, CPU, and other like measurement. And here is like for connectivity to the network, like this is connected. If it is showing 1, it is connected, and if it is showing 0, it is not connected. So like So to conclude, I can say that this project is highly beneficial for data analysts and farmers and the company as a whole. By analyzing the collected metrics, we can ensure successful agricultural production and achieve high quality yields on time. One of the advantages of AOT projects like this one is ease of development and modification. By simply installing and configuration various tools such as data collectors and monitoring platforms on Raspberry Pi, the system can be enhanced currently. So this is the whole project, and I hope you get my point, and thank you for your attention.
Thank you. Thank you. If there are any questions from the audience. No, I do have a question though, but can you hear us? Can you be short in answering my question? Okay.
Yes.
So my question for you is your solution somehow different from what it already exists on the market? And if yes, in which way?
I didn't see like someone or a company that already used this solution. But in the company that where I did my internship, they never used this, or for example, they don't know about this. So it's like a new creation for them. But it was existed before. I don't know really.
Okay, thank you.
Thank you. You're welcome.
And now for the last presentation today. If we have online Wafa Heri and Khalid Ben Musa,
Yes, I'm here.
Yeah, you're there.
Yes.
Okay, great. So please present your next paper entitled Reformulation of the Lesson-Raviat Discontinuous Galerkin Level Set Approach for Free Surface Flow.
Yes. Okay. Now we're starting. That's good. You can see.
Yes, we do. Perfectly.
Okay. So, would you like that? I think it's good now. So, hello everyone, and I'm pleased to present my work at this conference. Welcome to my presentation on reformulation of the Lausanne-Raviat discontinuous Galerkin level set approach for free surface flow. I'm Heri Wafa, a PhD student at Ibn Zohar University. Today, I will be sharing some insights and results from my research. So let's get started. Here is an overview what we will cover today. I'm going to start with an introduction, including the definition of free surface flow and its application. Next, I will discuss the mathematical model, focusing on the level set method, followed by its variational formulation. We will then move on to the two-phase flow, studying the Navier-Stokes equation and their variational formulation. Finally, I will share our numerical results for the Risen bubble test and conclude with the main findings. So let's start with the introduction. Here, where the free surface flow refers to the movement of a fluid with a deformable and mobile interface. When two immiscible fluids are present, they are separated by an interface as illustrated in the figure. And it is important to note that this interface is influenced by factors such as gravity, fluid viscosity, and surface tensions. And our work aims to accurately calculate these interfaces. Now that we understand the concept of the free surface flow, let's explore one of its application, the phenomenon of Risen bubbles, where in chemical engineering, capturing and understanding how bubbles rise in reactors like bubble columns is vital. It helps predict their behavior, improve mixing, and optimize chemical processes. Likewise, in petroleum engineering, capturing the interface of rising bubbles in gas lift operations optimize all oil productions and reduces costs. After we having explored the practical application to understand and simulate such phenomena. Let's start it with the level set method, which revolves around the function that's called the level set functions phi, governed by the transport equation 1. This method developed by Osher and Setien and employs phi to track the interface. In the context of our study, phi is assigned distant functions that equal 0 at the interface, positive in one fluid and negative in the other, as illustrated in figure 2. Well, the key advantages of this method include the easy formulation and computation, the smoothness of the functions phi for accurate numerical solutions of equation 1, and its capability to simulate complex interfacial flows with strong surface tensions. It also allows direct access to the local geometric characteristic of the interface, such as curvature K and normal N. Now, let's move on to the variational formulation of the level set method. Well, the Lausanne-Raviat method is based on a discontinuous approximations of the variable phi and each element K of the mesh. The elementary variational formulation can be written as follows.
where nk is the unit outward normal vector and the boundary, and here phi is the jump. Well, this problem was reformulated by adding a variable lambda, defined just in mesh, well, just in mesh faces, or we can say an edge in 2 dimensions. Then the new formulation will have the following form here, and it's equivalent to the discontinuous Galler-King method for the advection problems, and it's easy to implement in definite element codes. Now we go to the two-phase flow, and we consider the two fluids, 1 and 2, to be immiscible, homogeneous, incompressible, and each with constant density and viscosity. Then the fluid flow will be modeled by the following incompressible Navier-Stokes equations, where here F is the surface tensions forces. And to complete our problem, we apply directly boundary condition to the velocity and the initial condition. Besides, the system is also completed with the interface conditions imposing the continuity of the velocity for the first equation here, and the balance of the normal stress with the surface tensions across the interface here. And now, before moving to the variational formulation of the Navier-Stokes equation, we need to define some quantities related to the interface in two fluid flow, such as here we have density, viscosity, and interface forces. And to do this, we need to present the Heaviside functions, and that's it helps to define parameters with different values in each subdomain. For example, here we define the density of the fluid as follow, and we use a similar expression for the viscosity here. Additionally, the delta function here is used to define quantities on the interface, such as the surface tensions that is presented as a volume force here, with the sigma is the surface tensions coefficient. Well, for the Navier-Stokes equations, its variational formulation is given by the system 8. The existence of a solutions for this problem is derived using the same arguments as for the standard Navier-Stokes equations. The solutions is unique in 2 dimensions. Well, after outlining the mathematical model, let's now look at the numerical results obtained from our simulations. Well, our application involves the rise and deformation of a single bubble under gravity in a fluid contained in a vertical rectangular domain omega. Here, the bubble is we'll say that the bubble's density is lower than that of the surrounding fluid. For the simulations, well, in the absence of an analytical solutions, we utilize numerical data from the study by Heiser and al. As represented in Table 1. And 4 our simulations were conducted using the FreeFrame++ software. Here, illustration 4 shows the initial mesh used in our simulation after adaptations. And it is important to note that the approach to solving this problem is performed in a decoupled manner. First, we solve the Navier-Stokes equation to determine the velocity, and then we use this velocity in the transport equation to calculate the new position of the interface. Well, our first result is the shape of the bubble at the final time t equal 3. Our results are shown in the left panel, and those of the Heiser and all are shown in the right panel, and both display the same shape. And we also observe that the maximum width and height are similar. And then we also compared the evolution of the center of mass, which can be represented as a linear functions, like we see here, as a linear function of time and approaches y equal 0.8 by the end of the simulations, as confirmed by the figure. And for the rise velocity, it shows a stable maximum reaching a value of 0.24 around psi equal 0.9. And here, for the second test case, the bubble gets more deformed because of the lower surface tension. And we can see that some skirts here appear to the bottom. We can notice that the final shape of the skirted bubble is very sensitive to the mesh size, and none of the groups agree on the exact shape, which can explain the difference that we can see the parameters in the figure 8 and 9. In conclusion, we apply a novel Lucent-Rabier formulations to the transport equations of the level set method, and this method is stable and conserve volume, and we use the Raisin bubble problem as a benchmark to illustrate the relevance of the proposed method. And finally, this approach is valuable in fields where the inflow fluid into the domain is unknown. And here are some reference guiding our research. And thank you for your attention.
Okay, thank you. Thank you very much. If we have any questions from the audience.
Thank you.
No, we don't. So thank you all for this very fruitful meeting today.
Thank you. Thank you so much.
Thank you, everybody, and I declare this day over. And we'll see again each other tomorrow morning, I suppose. Yeah, tomorrow morning. So thank you, everyone, and have a great afternoon from now on, or night, or whatever time is for every time zone there. Okay, so thank you and have a great night. Bye-bye.